Hi, my name is Don Briggs and I'm a member of the team at Breadboard Electronics, and this is project number 21 based on our starter kit. This again is a fairly straightforward flasher with a 555 timer integrated circuit. The first circuit is just basically an A-stable and toggles between two LEDs, and the second circuit is almost identical, but we've swapped out the variable resistor VR1 for a thermistor so that we can have the LEDs react based on temperature. Now, the first circuit, if we look at the VR1, if we change the value of that, it will change the speed rate, slowing it right down now, as you can see. Now, the circuit at the bottom, we have a little thermistor put in here, and as you can see, the LED is not flashing very fast, but as we increase the temperature, the flash rate becomes faster and faster until it gets so fast you can't hardly see them on. Not a brilliant little circuit to play around with, get it working. Can have that on your bedside table, maybe wake you up in the morning, or not. Here's the breadboard representation of that. I'll explain the one on the right in a minute, but for now we have literally just a flasher we got the potentiometer in there this time. Again, yeah, they're flashing quite fast and slow right down to virtually nothing. Ideal, brilliant little circuit. Now, the bit on the right is a little breadboard idea I came up with when I was first working with timers, to get all the pins in one line from 1 to 8. And I found the easiest way to do that is just to do something like what I've done here. Similarly with LEDs, if you're constantly using LEDs, rather than keep finding them and plugging them into your breadboard, have some way of having some there semi-permanently. Maybe you could have a resistor on that block as well, and then just plug directly into it. It's just my way of helping me learn, if for want of a better term, and keep it tidy when I was trying to do things in the early days. I've also showed the pinouts of the 555 timer, just to give you a rough explanation of what it does. Now, I could explain the pins. I think actually I could explain the pins better if we probably go back to here. Now, very commonly, pin 2 and pin 6 are joined together. Pin 4 and pin 8 are joined together, and that is very common for a lot of circuits. It's by no means all circuits, but a lot of them are. More often than not, we have this potential divider effect here, with pin 7 going to one part and the pin 6 and 2 combination going to the other part. What else is on there? Pin 3 is the output, and pin 4 and pin 8 go to the live rail of some description. And pin 5, you might find a small capacitor in there, very small capacitor, but it's, again, for prototyping, it's not worth the effort of putting it in. You'd want to put one in if you have a live circuit that you wanted to keep, you wanted to solder it, you might put it in them, but generally for prototyping you wouldn't bother. You won't notice anything wrong, there's nothing for it to affect, so basically you could leave it out. I think that's it for now. That's the end of project 21. Thank you for watching.
Hi, this is project 21. It's another flasher with a 555 integrated circuit. 555 is sitting down there, and those of you that have actually seen the previous videos, most of this circuit is identical to the others that use a 555. This one, it just toggles the flash between the two LEDs. We give it some power, and there we have a flash. And if I change the trimmer, we could change the rate that it flashes, right up to a point where it's almost on all the time. Fantastic. That's the end of project 21. Thank you for watching.